Upfront Books presents The Evolution of Nuclear Strategy, 4th edition, written by Lawrence Freedman and narrated by Richard Elwood. Preface. When this book was first published in 1981, it was 36 years since the first and still the only use of nuclear weapons in anger. At the time of publication, tensions between the United States and the Soviet Union were on the rise, and the nuclear issue had moved to the center of political debate across the Western world. A nuclear war was being actively discussed as a real possibility. This new edition is published with another 38 years having passed. There have been many terrible events during these years, including vicious conflicts that have left millions dead, wounded, or displaced from their homes, but still a catastrophic nuclear war has been avoided. This fortunate state of affairs means that this 4th edition, like the 2nd and 3rd, can tell a continuing story of non-use while considering the preparations for war, as well as attempts to reduce the risk through measures of disarmament and arms control. Unlike the 2nd and 3rd editions, however, which added new chapters to describe developments since 1981, this edition not only updates the story of nuclear weapons, but also provides a complete revision of the original book. There are a number of reasons for this updated and revised edition. The most obvious is that a mass of material has been published since 1981 on the first decades of the nuclear age, adding to our knowledge of the major strategic thinkers of the period, and also the relationship between how the key issues were debated in public and how they were viewed by policymakers in private. This is also true for the periods covered in the 2nd and 3rd editions. In particular, we now know a lot more about the development of Soviet nuclear strategy, so the account can be less one-sided. The opportunity to compare the internal policy debates with what was being discussed in public makes it easier to evaluate the actual influence of some of the big books and ideas in contemporary strategic theory. Secondly, while it remains the case that the innovators in nuclear strategy have largely been American, with many more nuclear states and the Cold War over, it is important to review not just superpower strategies, but the whole range of approaches to the nuclear issue, including those of states that decided that they could abandon their weapons programs. Third, it is hard to get a unity of style when bringing together chapters written at different times over the past 40 or so years. Both Freedman and Michaels wish to acknowledge their debt to their colleagues and students at King's College London. Michaels is also grateful for the backing of the John D. and Catherine T. MacArthur Foundation and the support of Professor Wynne Bowen. London, UK. Lawrence Freedman, Geoffrey Michaels. Introduction. Just after 7 a.m. on the 6th of August 1945, a single aircraft flew over the Japanese city of Hiroshima. This B-29, known as Straight Flush, was checking weather conditions over the primary target for the dropping of the first atomic bomb. 2 other aircraft were checking the conditions over the 2nd and 3rd possible targets. The all-clear was sounded in the city below as the aircraft flew away. Another B-29 named Enola Gay after the mother of the pilot, Colonel Paul Tibbets, now prepared to drop the bomb it was carrying. 2 other B-29s followed just behind, carrying scientific instrumentation and cameras. One was named Great Artiste, and the other was later named as Necessary Evil. An hour later, at 8:15 a.m., the bomb was dropped. At least 66,000 people died almost immediately from the explosion and firestorm that followed. Tens of thousands more died in the aftermath, and many died over subsequent years as a result of their injuries and exposure to high doses of radiation. 3 days after the first explosion, a second bomb was dropped on the Japanese city of Nagasaki. The immediate dead numbered some 40,000 people. The hilly terrain meant that the devastation was not as complete as with Hiroshima, although the explosion was larger. About 40% of the city's structures were destroyed or severely damaged, as against 80% in Hiroshima. On the 15th of August, Emperor Hirohito announced Japan's surrender. Thus began the nuclear age. It opened with key propositions. The bomb's effects were devastating, cities were their natural targets, there was no obvious defense, and they could win wars. Each of these propositions could be qualified or challenged. When announcing the destruction of Hiroshima, President Truman had described the target as an important military base. This choice of words, indicating unease about targeting civilians directly, foreshadowed later debates about the purposes that might be served if nuclear weapons were directed against the enemy's armed forces. Those who had planned the attack were surprised by the death toll. They had assumed that people would have taken shelter, not realizing how little alarm would be caused by the appearance of so few aircraft. As the weapons became even more powerful, the possibility of surviving an attack declined, but concepts of defense based on intercepting weapons before they reached their targets continued to be explored. Later, a debate began about whether the destruction of these two cities really did cause the Japanese surrender, especially as the Soviet Union coincidentally declared war on Japan. But first impressions count, and these reinforced the view that atomic bombs were transformational weapons. Despite their apparent ability to win wars, the horrific human consequences of their use raised questions from the start as to whether they could ever be treated as normal weapons of war. Soon the emphasis was on deterring wars rather than winning them. This preference was reinforced once the Soviet Union acquired its own nuclear capabilities and the US monopoly was lost. In this respect, the context of the developing Cold War between these two countries and their respective alliances shaped thinking about nuclear weapons. If the victors of 1945 had avoided a new round of conflict, then they might have been able to work together to impose stricter controls on how nuclear energy was exploited for military purposes. Proposals were made, but they soon foundered on Cold War suspicions. In these ways, the big issues of targeting, survival, deterrence, and control were framed from early on in the nuclear age, and they continued to shape debates about their development, deployment, and potential use. The weapons that destroyed Hiroshima and Nagasaki produced explosions equivalent to that produced with roughly 14,000 and 20,000 tons of TNT respectively, an explosive power described as being 14 or 20 kilotons. Many of the nuclear warheads now in the possession of the major powers are in the megaton range. That is, they would result in explosions equivalent to that produced with 1 million or more tons of TNT. If a 1 megaton bomb is exploded at the height necessary to achieve maximum destruction, all brick houses would be destroyed out to 3.5 miles, with comparatively minor damage out to 13 miles. The blast would create winds sufficient to hurl objects and even people through the air at lethal speeds out to 6.5 miles. Within a radius of about 6 miles, most fabrics and paper will burst into flame. As far out as 11 miles, the explosion could cause second-degree burns and ignite dry leaves. The explosion would take its toll in human life for the following weeks and months through radiation sickness. Plans for war during the first decades of the nuclear age assumed that any use would be on a massive scale. Later, it became possible to envisage use on a limited scale, especially in a war between the smaller nuclear powers. It is unclear at what point in a nuclear war there would be a breakdown of social organization, with the consequential economic collapse and the spread of poverty, disease and hunger, nor the nature of the political and social consequences, although they would always be extreme. One of the most profound thoughts to develop during the 1950s was just how quickly all or much of this could be accomplished. If the deed were to be done, it could be done quickly. It remains within human decision. Our collective future has become hostage to continuing acts of self-restraint by the leaders of the world's major powers. It is not surprising that, at times, these leaders did not and still do not seem wholly suited to this responsibility, or that events appeared to be propelling them to a point where caution, and eventually everything else, might be thrown to the winds. Mass movements were mobilized on the basis of such anxieties and pushed the question of prevention of nuclear war to high on the political agenda. The remedies proposed ranged from attempting to make nuclear weapons more usable by controlling their effects to making them virtually impossible to use on the grounds that their effects could never be controlled. Some addressed the problem as essentially one of command and control. Others were concerned with the size of the nuclear inventories and argued that they could and should be reduced dramatically, if possible, to zero. Advocacy of a nuclear-free world continues. Proponents of nuclear disarmament have been regular winners of the Nobel Peace Prize, no less than 8 times, most recently the International Campaign to Abolish Nuclear Weapons, ICAN, in 2017. The only prize for an advocate of deterrence was to Thomas Schelling in 2005, and that was for economics and not peace. Despite the advocacy and the practical work done on how to move to a nuclear-free world, this remains a distant prospect. So long as we do not have a conflict-free world, so long as nuclear weapons remain attractive as symbols of power, and so long as the fear that the widely spread knowledge of how to develop and produce nuclear weapons will be exploited by the unscrupulous, there will continue to be limits placed on the possibilities for complete disarmament. Even if current stocks were eliminated, during the course of a conflict, new stocks could be produced, especially if civilian nuclear facilities had not been eliminated. Nor do nuclear explosions exhaust the possible horrors that human beings can inflict on each other. More positively, the record suggests, even if it cannot prove, that the risk of nuclear disaster has been the source of a welcome caution in international politics over the past 7 decades. For the moment, it is as difficult to comprehend a future without nuclear weapons as it is to comprehend the consequences of their use. This book is largely concerned with a different problem. Given the horrific consequences of their use and the possibility that any use might lead to retaliation in kind, how do states attempt to incorporate nuclear weapons into their security policies? Can they be used to deter any war between nuclear powers, or just nuclear use in those wars? In the event of war, how might they be employed to gain a military advantage? To what extent does the credibility of deterrence depend on forms of effective and potentially decisive use being identified? Though these are questions that have preoccupied some of the best minds of our time, there have been no definitive answers. The thankful lack of experience of nuclear warfare since 1945 has rendered highly speculative all thoughts on the likely causes of nuclear war, its course, and its finale. Even when nuclear powers have confronted non-nuclear powers, they have yet to take advantage of their supposedly decisive superiority. The likely dynamics and consequences of nuclear employment remain matters for inference and conjecture. There are many aspects to the history of nuclear weapons: the science behind them, the construction of the first weapons and their use, the various means of delivering them and how these have been developed over time, forms of defense, practical steps to achieve arms control and disarmament, their role in holding together alliances and managing crises, proliferation and the possibility of terrorist bombs, and so on. All of these matters need to be considered in a history of nuclear strategy, which is the focus of this book. As strategy is concerned with the relationship between political ends and military means, our interest is with the theoretical and practical issues raised by attempts to extract political benefits from nuclear arsenals. Unlike most military strategy, which is about how forces might be employed against armed opponents, the discussion of nuclear strategy has been bound up with deterrence and how to cope if it fails. Deterrence is a notoriously difficult subject to pin down, for it succeeds when nothing happens, and depends on how threats are communicated and understood. At moments of crisis, governments do talk about the risks of nuclear war, but at other times they tend to avoid speculating on the circumstances in which nuclear weapons might be used. The evolution in this book's title suggests a learning curve, implying steady progress in levels of understanding. Though in some respects that is true, because there has at least been an accumulation of knowledge, there is also a marked cyclical character to the debates. Moreover, if there is an underlying trend, it may be less towards the refinement of a theory strong in its inner core, but towards a steady resistance to the idea of an operational nuclear strategy. Operational concepts are still developed and plans are made, but any implementation must confront the likelihood that the repercussions of use, foreseen and unforeseen, will outweigh any gains. To make sense of all this, and to keep these strategic debates in context, requires addressing a vast and rich literature. It is difficult not to be overwhelmed by the sheer volume of the material that has been generated. In addition to professional writings of writers from the military and reflections of politicians presiding over nuclear arsenals, there has been a vast outpouring of books, articles, papers and memos from civilians representing many academic disciplines and often organized into new research institutes concerned with few things other than the problems of modern strategy. As time has passed and archives have become declassified, a vast documentary record of high-level deliberations, war plans and nuclear guidance has become available. The literature threatens to overwhelm any would-be historian of ideas. To help order and explain such a novel situation, new and arcane concepts have been developed, which sometimes serve to clarify, but often only obfuscate. The uninitiated has to work through a forbidding miasma of acronyms and jargon. An attempt to note each intended contribution to contemporary strategy would result in a work of great length and tedium. Inevitably, a large proportion of the material is repetitive and derivative. In the same way that a military historian is not expected to record every campaign, so a historian of ideas does not have to record every documented thought. This work is selective, and in consequence the discussion of some areas, such as conventional strategy, and particularly naval warfare, is inadequate. Also, we have concentrated on the strategic debate in the United States, the most vigorous and fertile, though without neglecting the parallel debates elsewhere. Over time, these parallel debates have become more important and distinctive, which is why they receive additional attention in this new edition of the book. The aim is to provide a systematic and reasonably comprehensive treatment of the major themes of nuclear strategy. To this end, the most important individual contributions to the debate have been analysed in some detail, but this is not a collection of critiques of great texts, and so some favourite authors may not have got the attention they deserve. Similarly, while this is also not a history of decision-making, we have sought to check declared policy with what was being said in private meetings in governments and international organisations. The number of strategic debates to be addressed has expanded with the number of nuclear powers. As these new powers face different challenges to those of the original powers, we have explored the extent to which they have shown strategic innovation or have been caught by the same dilemmas and formulations which caught the others. A book about strategy ought to begin with a definition of the subject. A comparable book in the Soviet Union would have opened with elaborate distinctions between military strategy, art, science and doctrine, but, as indicated above, we have avoided restrictive terms of reference. Furthermore, there has been no constant and generally accepted definition of strategy, even during the post-war years. The origins of the word strategy lie in the Greek strategos, meaning the art of the general. The word returned to the European vernacular in the late 18th century, just in time for the Napoleonic Wars, but it was defined largely in military terms, as military thought was fixated on battle. Strategy was about getting into the best position for a battle. Tactics was about how it should be fought. By the 20th century, it was becoming harder to avoid questions of policy, covering peacetime preparations for future wars, including alliance formation, the purposes for which they might be fought, and the mobilization of all national resources, economic and political, as well as military, to win them. The relationship between military means and political ends was captured during the interwar years by Basil Liddell Hart, the art of distributing and applying military means to fulfill the ends of policy. It was non-committal about how military means were to be distributed, while stressing the role of the political sphere as the source of strategic objectives. It also maintained the connection with military means. This is why Liddell Hart's definition still works, even in the nuclear age. The difference that nuclear weapons made to the concept of strategy was to turn the focus away from war fighting to war prevention, and to forms of coercion and intimidation, including deterrence, as well as crisis management and arms control. When all the means of national power, political and economic as well as military, are being considered, this is now normally described as grand strategy. It is reasonable to consider this wider context of diplomacy and general international relations, but it remains important to remember that we are dealing with functional and purposive violence. A further complication comes with the particular way the term strategy has come to be used in connection with nuclear weapons. When fledgling air forces after World War I were anxious to demonstrate that they possessed a means for getting right to the heart of the enemy's power and destroying it with some well-chosen blows, they described this as a strategic capability. Thus they spoke of strategic bombardment, using strategic bombers, eventually under a Strategic Air Command, SAC. In this spirit, nuclear weapons best able to perform this mission came to be known as strategic weapons, and a war in which they were to be used would be a strategic war. This use of the adjective strategic has very little to do with the noun strategy. The connection has now become even more tenuous, with strategic now tightly defined, as in the strategic arms reductions talks, by reference to the ranges of certain weapons. A weapon that can be directed from the homeland of one superpower against the homeland of the other is strategic. Nuclear weapons designed to be used against enemy forces in battle were described as tactical, although any authorization to use even these smaller-scale weapons would still be a highly strategic matter. It is difficult to avoid this sort of terminological usage, as it became the language in which nuclear issues are discussed. It also indicates the extent to which the dramatic entrance of atom bombs onto the international stage meant that they were discussed and understood in terms derived from the established theories of air power. Eventually, nuclear weapons became more powerful, more numerous, and, crucially, possessed by more than one nation. New concepts and approaches developed in an attempt to come to terms with the possibility of a war in which the use of the most formidable weapons available would mean, in all probability, that it would be catastrophic for all concerned. Could any useful purpose be served by employment of devices which invited discussion using words such as Holocaust, Doomsday, and Armageddon? And could any employment of nuclear weapons be sufficiently deliberate and controlled to ensure that political objectives were met? At issue has been whether a nuclear strategy is a contradiction in terms. To the extent that there has been an effective nuclear strategy thus far, it has depended on non-use by deterring major war and helping to hold together alliances. The most intense debates over nuclear strategy took place during the Cold War, but though that ended many years ago, the weapons remain ready for use. Behind the question of whether strategies based on non-use still have a role to play is the even larger question of whether it is possible for the habit of non-use to be sustained. There has been no use of nuclear weapons since August 1945. It is an impressive record, but is it one that can be sustained indefinitely? Chapter 1. The Arrival of the Bomb. Nuclear strategy was the product of two lines of scientific and technological development, both of which can be traced back at least to the start of the 20th century. The first, which began with the study of radioactivity, concerned the structure of the atom and the amounts of energy that might be released if the circumstances in which atoms broke up could be better understood. The second was the possibility of heavier-than-air flying machines, which had been discussed during the previous century as a possibility and became a reality in 1903 when the Wright brothers completed the first manned flight at Kitty Hawk, North Carolina. A textbook image of the atom is one of a small solar system, with a heavy, positively charged nucleus made up of protons and neutrons orbited by light negative electrons. As each atom is electrically neutral, the number of protons in the nucleus is equal to that of the outer electrons. The atomic number of an atom and its fundamental chemical properties is determined by this number of protons. The number of neutrons in atoms of the same element is not necessarily constant. Variations which can lead to differing properties are known as isotopes. They are distinguished from one another by quoting the total number, neutrons plus protons, of particles contained in the nucleus, e.g. uranium-235. A key characteristic of neutrons, which makes them potential agents of change in a nucleus, is that they are uncharged. Only certain combinations of neutrons and protons are stable. When few in number, equal amounts of protons and neutrons result in stability, but for larger nuclei, the proportion of neutrons required for stability is much greater. The potential instability of certain atoms to the point where one element transmutes into another was originally explored through the study of radioactivity, a term coined by the French scientists Philippe and Pierre Curie to refer to the emissions they detected coming from unstable isotopes of heavier elements. These discoveries began in the late 19th century. Almost immediately, the possible military implications of the energy contained in individual atoms being released was recognized. The futurist H.G. Wells, who had already contributed a dire warning on the impact of air power, published The World Set Free on the eve of the First World War, which imagined pilots throwing atom bombs onto enemy cities. As the workings of the atom came to be better understood, other works of fiction also discussed the possibility. In Harold Nicolson's Public Faces, 1932, a British atomic test accidentally destroys Charleston, South Carolina, as well as several other American cities. Nicholson was provided the name atom bomb and technical information from science writer Gerald Hurd. Other fictional works during this period discussed the atomic bomb specifically, as well as the weaponization of atomic-related components, for instance radioactive dust, and dealt with such issues as atomic demonstrations, deterrence, the failure of deterrence, and disarmament. 1932 was the year in which the neutron and its role was identified by James Chadwick. That year, experiments by Enrico Fermi involved fission, but he misunderstood his results and offered an alternative explanation of the phenomena he had observed. In 1933, Leo Szilard, an émigré scientist born in Hungary living in London, who had read the books by both Wells and Nicholson, was bothered by a report of a speech by one of the pioneering students of radioactivity, Ernest Rutherford. Rutherford was of the view that transforming individual atoms would be an inefficient way to release energy. According to Szilard, the reason why Rutherford was wrong came to him as a revelation as he crossed a road. If the neutrons released when individual atoms were split in turn went on to split other atoms, then a chain reaction could result, resulting in a massive release of energy. So alarmed was he by this discovery that he patented his description of a self-sustaining chain reaction in secret. In December 1938, Lisa Meitner, an Austrian scientist who had moved to Sweden to escape the Nazis, heard from the German Otto Hahn of an experiment in which uranium appeared to turn into barium. With her nephew, Otto Frisch, she realized that incoming neutrons had caused the uranium atom to split. This phenomenon was named fission by Frisch because of its similarity to the division of a biological cell. As a result of this intensive period of research, by early 1939 the international scientific community understood that when uranium atoms were bombarded with neutrons, they could split into approximately equal parts, with the release of enormous quantities of energy. They also knew that when fission occurred, some free neutrons were released, which were capable of causing fission in other nuclei, which could, in principle, result in a chain reaction, spreading through a mass of fissile material and yielding enormous power. An atom or fission bomb was therefore a theoretical, if not yet a practical, possibility. It required a chain reaction to create an explosion. This required an amount of fissionable uranium or plutonium isotopes, U-233, U-235, or Pu-239, to reach a critical mass from which free neutrons could not escape or be captured by non-fissionable material. In addition, for explosive purposes, this reaction would need to build up extremely rapidly, for otherwise the device would fly apart and the reaction would stop. It was the brevity of this period that caused most technical problems in the construction of the first bombs. As governments became aware of these developments, and with the real possibility of another European war, members of this international community had to pick sides. A German nuclear weapons effort began in April 1939, although many Jewish scientists, who would have made a significant difference to the project, had fled and came to make vital contributions to the British and then the American projects. The lukewarm attitude of many German scientists to the project, and Hitler's belief that the war could be and had to be won quickly before such a weapon would be necessary, hampered its progress. In Britain, Winston Churchill, who had long taken an interest in nuclear energy, in part because he read closely the works of H.G. Wells, accepted a recommendation to establish an investigation into the possibility of an atomic bomb in June 1940. By July 1941, enough work had been done to demonstrate that a new and more powerful bomb using uranium might well be feasible. The key paper was written by Frisch, now based in Britain, and another émigré scientist, Rudolf Peierls. In the United States, Szilard persuaded Albert Einstein, the most famous scientist of his day, to write to President Roosevelt, warning of the possibility of
Sample complete. Ready to continue?